Hey guys, and how you doing? And today I want to do some more on image processing again, but this time I want to go over classification of pixels. So in classification, we are trying to do one of two things. First off, we're trying to maximize the distance between classes, maximize between class differences, which basically means that we're trying to separate two individual bodies. So if we have like brunettes and redheads, we want to make sure that those two groups are as far as possible away from each other. And then we also want to minimize within class variability. So when we have a class of those brunettes or of those redheads, we want to make sure that they're standing as close as possible together in their individual groups. So with the brunettes, we want them to stand in a close-knit group in one area, and we want the redheads to stand in a close-knit group in the other area. And so classification in this way can be done in two forms. These are supervised classification and unsupervised classification. You can probably also see Sentdex's machine learning tutorials for this, and you can look back at where I've suggested which one of those videos they are in a previous video somewhere. Anyway, supervised classification uses representative or training sites, by which I mean you use the region of interest tool, as we've used previously in those last couple of videos. So, and you're doing this to train a classifier. So you do this by selecting a specific location, like a water body, as a section of the map and saying, map, this is water. So you select an area of water and you say, okay, computer, this is what water looks like. I want you to select all the water areas based on what I've shown you what water looks like. So yeah, I want you to look at places that exhibit the same characteristics as this region that I've just shown you. This produces what's called information classes. So information classes are classifications defined from land cover type. So the steps to do this are essentially an analyst selects training sites for the required information classes. The training data can be a region of interest or an ROI. You can also use segments or spectral field signatures, and we'll go through segments a bit later at the end of this video. So you want to then calculate statistics for each training site, select classification algorithm, by which I mean how you determine classes should be defined, and that's really the Sentdex's part that I'm referring to. The classification algorithm is how you defined data separation and how data get their values and all that. And then the next step is analysts put specified training sites into classification algorithms, and then each image pixel is assigned to an information category based on its statistical similarity to the training site for that information class. And then you have an output map of information classes. So that simplifies classification, and then there's also the other one, which is unsupervised classification. This is for when you are not familiar with the study area and you use an automatic process for finding groups of similarly valued pixels. This produces spectral classes. So spectral classes are defined in spectral space and they're not associated with land cover type, unlike with supervised classifications where they are defined by the land cover type. Anyway, so in unsupervised classification, the steps are essentially you want to apply an algorithm on a corrected image, define the number of, breaking this down, you want to define the number of spectral classes, define the algorithm, so for example, K means clustering. You want to run the algorithm to define clusters of pixels in spectral space, where spectral class values are algorithm-defined training sites. And then you want to have each image pixel to be assigned to a spectral class based on its statistical similarity to the training site for that spectral class. And then the spectral class values are computer-defined training sites input into classification algorithm. So basically, to summarize this, in the supervised classification, you show a computer, this is what a water hole looks like. I want you to mark all the other water holes. But in unsupervised classification, you don't know what is on the land. So let's imagine that you don't know what a water hole looks like. So you tell a computer, like the parameters of like values it should be accepting, like wavelengths it should be accepting or something. So it's a lot more. I'm not showing you an example of what a bird looks like. I'm going to tell you the characteristics of a bird, and I want you to define all the groups of birds, rather than me giving you a picture of a bird and saying I want you to define all the other pictures of birds that you see on this piece of paper. Then there's also hybrid, which uses both. Importantly, it uses supervised for known cover type areas and unsupervised approach to cover those areas unable to be classified in the supervised approach. So here's an example of the hybrid steps, and this can be done in either way. So supervised can come first, or it can come second, or unsupervised can come first, or it can come second. So unsupervised to supervised, you might apply a k-means to selected subimages. So you want to identify label classes, and then you merge classes from different subareas, and then use spectral classes to classify the entire image. And then you want to be selecting training sites in areas left unclassified by the spectral classes. And then you can also do supervised to unsupervised, where you want to train the classifier on known cover types, and then the remainder is classified by unsupervised approach. So essentially, you're just doing the supervised then the unsupervised, or you're doing the unsupervised then you're doing the supervised. So are you showing it? Are you showing it an example of a lake and then it doing the rest of the lakes? And then I don't have an image of a house, so you have to do unsupervised so that the computer will just look at all the houses, because you don't know what a house looks like, or you don't know if houses are on the land, let's just say. You could be like super zoomed out and you don't know what is and isn't a house. So you say, computer, I'm going to show you what a lake looks like. Now I want you to circle all the other lakes, but I don't know if there's a house, so I want you to circle all the possible houses based on what I define as a house. But obviously I haven't given an image I haven't given you like a reference example. That's probably a better way of putting it. I haven't given you a reference example to look at to know if you're right or not. So which means that in a unsupervised classification, the computer can be wrong. It can give you like, it can give you like a lake when it's supposed to give you a building, because it classified it wrong. It thought the lake was a building, but it wasn't. Anyway, next I want to move on to object-based classification. And to summarize OBIA, or object-based image analysis, it creates image objects through use of polygons. And object-based analysis is good when working with patterns. For example, grey shopping centre areas surrounded by black roads, or you might have like a farmland area surrounded by gravel roads or dirt roads or something. So you can, so in object-based image analysis, you want to select something which has typical characteristics which can be duplicated. It's kind of like a supervised classification almost, but unlike a supervised classification, you're using polygons. That's the major difference. So, like, I'm gonna give you, say, like a lake, and this will be an object, and then all the other lakes I also want to be be as objects as well. So it's good with relationships of blocks of pixel values. And so we do OBIA because pixel-based image analysis has limitations in color and in texture. So grouping like patterns of color in objects may be better. And in OBIA, we are using a parent-child method of either breaking or amalgamating blocks into similar groups. Once done, so we could then use classifying algorithms then. And finally to this video, I want to talk about sub-pixel classification. So in sub-pixel classification, just know that a pixel, say of like 5 by 5 meters, it can have like a tree and the road beside it in the same pixel. So this is spectral mixing, and you can see in this image on the screen here that I have a few different layers of like colors. And so that's getting closer to like soil and vegetation or whatever it is. And so you might want to have more soil or more vegetation, because in a pixel it has soil and vegetation in it. So you might want to only be looking at vegetation or only soil. So that's what spectral mixing is, and you see that in those two graphs there. Spectral unmixing. This is where all bands are removed or added in difference to get a total value low or high. So if you look at the left graph here, moving from the right graph, in the right graph there are a number of different levels in that graph of different colors, those lines, but we don't want to get all of those different levels. We want to get just grass or just soil, for example. So you can see it moves into the left graph, which is just two lines, one which is all soil and one which is all possibly grass, for example. And so in fuzzy subpixel classification, which is our final slide, we would account for gradual transition between cover types rather than precise, distinct boundaries. And you can see that in this slide right here. So in the topmost view, you can see conventionally in classification, it's either false or it's true. So it either definitely is water or definitely is forested wetland, or it's definitely upland forest. It can't be any of the other two. It can only be just the one. But in fuzzy classification, it's a slow gradual movement between the other classifications. So it's not definitely just water or definitely not just water. It can be water as a percentage, and closer to 1 is of course 100% water, and closer to 0 is 0% water. So that's the fuzzy classification method for subpixel classification. And anyway, I hope you guys have learnt a lot. The only other final step would be removing outliers and errors that I've gone through previously. And so anyway, I hope you guys have learnt something, and I hope you'll stay tuned to the series, and I hope you will continue to learn something on my channel. Anyway, have a great time guys, and good luck.